Welcome, chemistry students! This video will focus on lesson 3 of your General Chemistry 1. This will cover chemical reactions and will have two topics. One is balancing chemical equations and number 2, types of chemical reactions. For the objective, we will write and balance chemical equations. Let's first define a chemical reaction. What is a chemical reaction? A chemical reaction is any process that involves a change of a substance into another substance. So every time a substance is transforming or changing into another form of substance, we can tell that the substance is undergoing a chemical reaction. So what are the evidences of chemical reactions? When can we say that a chemical reaction is taking place in a substance? So there are evidences or indicators. One is change in color. So you will see here that a piece of banana is changed from yellow-green to brownish. So that indicates that a series of chemical reactions have happened to banana that made it change its color from being fresh look to rotten look. So change in color is one of the evidences or indicators of chemical reaction. Another is, so you have observed this many times, the formation of bubbles here is a result of a chemical reaction. That is actually carbon dioxide produced from the reaction of a particular substance with carbonated drinks. Another is, so you will see on this illustration, formation of two gases. So evolution of gas is another indication of chemical reaction. For combustible materials, there are combustible materials that when burned, you will see formation of light. So formation of light is another indicator of a chemical reaction. Okay, on this picture, you will see two liquids that are mixed together and then forming a solid. So that solid that is forming from mixture of two or more liquids is called precipitation. Precipitate. So the formation of precipitate is another indicator or evidence of chemical reaction. So those are the evidences of chemical reactions. They can help us tell whether a substance or a form of matter is undergoing a chemical reaction. Now, how do we represent chemical reactions? We use chemical equations. What is a chemical equation? A chemical equation represents a certain chemical reaction. So whenever you see a chemical equation wherein you will see symbols, formulas, so you could bear in mind that there is a chemical reaction that is being represented by that equation. So what will you see on a chemical equation? You will see chemical symbols and formulas in a chemical equation. So chemical equation is a shorthand representation of a chemical reaction where you will see symbols and formulas. Let's have this hypothetical reaction. So let me read. Heating substance solid A reacts with liquid substance B, produces precipitate C, aqueous D, with evolution of gaseous substance E. The reaction is reversible. So this hypothetical reaction can be represented by this chemical equation. So just like a mathematical equation, a chemical equation has two sides, the left side and the right side. On the left side, you will see the symbols or formulas of the substances that undergo the reaction and are called reactants. On the right side of the equation, you will see the formulas or symbols of the substances that are formed after the reaction and are called products. Okay? So what do you see on this hypothetical chemical equation? You will see symbols. You will see capital letters. These capital letters represent the substances involved in the reaction. As we have read earlier, there are 5 substances involved in the reaction. They are represented here as substances A, B, C, D, and E. So these capital letters are representations of the substances in the reaction. There are 2 reactants represented by symbols A and B, and 3 products represented by letters C, D, and E. So those are the representations of the substances involved in the reaction. One of the other symbols that you can see is the plus symbol. What does the plus symbol mean in a chemical equation? You will see the plus symbol on both sides of the equation. Why? Because symbol plus literally separates two reactants or two products. So to separate if you have two or more reactants in a reaction, because there are reactions that have one reactant. So in this case, we have two reactants and three products. So to separate the formulas in a chemical equation, we make use of the plus symbol. So aside from the plus, we also have the small letters. If you have the capital letters A, B, C, D, and E, we also have small letters S, L, and AQ. In addition to this, we also have small g. These letters represent or give us the physical states of the substances. So to interpret the reaction here, we have solid A reacts with liquid B to produce substance C, aqueous D, and substance E. Aqueous means in water, with water, or dissolved in water. So what else? We also have 4 different arrows. We have arrow towards the right, towards the left, upward, and downward. So what do these arrow mean? They mean different things. Okay. First, let's have the double arrow between the left side and the right side. Why do we have double arrow? As read earlier, our hypothetical reaction is reversible. So to indicate a reaction that is reversible in a chemical reaction, we make use of a double arrow, meaning A and B will combine to form the substances C, D, and E. C, D, and E can combine again to form again A and B. So the process is reversible. So to indicate that in a chemical equation, we make use of the double arrow. What else? What about the arrow down? So in the statement, in the reaction earlier, we mentioned the substance C was formed as a precipitate. So meaning, substance C here was formed after the reaction as a precipitate. What about the arrow up? It was also mentioned earlier that substance E is evolved as gas. So the arrow up indicates that the substance E is evolved in the reaction as gas. What else? We have one left. We have the triangle. Triangle here over on top of the arrow to the right means there is energy involved in the reaction. So it may be in the form of light energy, heat energy, or electrical energy in the case of electrolysis. So those are some of the common symbols that you will see in chemical equations. Moving on, let's have this simple reaction. Water, when heated, decomposes to hydrogen and oxygen gases. So let's identify first the substances in the reactions. We have 3: water, oxygen, and hydrogen. Which among these is or are the reactant or reactants? Which is or are the products? Let's analyze the reaction. Water is being heated and decomposes to hydrogen and oxygen. So this means that we have one substance that is undergoing the reaction and is transforming to two new substances. So we have here as the representation in a chemical equation, we have H2O is the chemical formula of water in the liquid state. Unless indicated, water is always assumed to be liquid at room temperature unless specified in the statement or in the reaction. So water, the heat energy is indicated by the triangle over the arrow to the right. So water is heated to decompose or to form two substances, new substances, hydrogen and oxygen gases, which have the chemical formula H sub 2, O sub 2, and which are both gases. Talking about chemical equations, we always associate balancing. Why do we always need to balance chemical equations? That is to conform with what we call the law of conservation of mass. If you recall, one of the 5 postulates of Dalton's atomic theory, it states there that atoms during ordinary chemical reactions undergo rearrangement. So matter, even if it undergoes chemical reactions, chemical change, is neither created nor destroyed. So when do we say that the matter is conserved? So at a molecular level, we balance chemical equations. And when do we say that a chemical equation is balanced? We take a look at the numbers of atoms of each element on both sides of the equation. So we describe a balanced chemical equation as an equation or a reaction with numbers of atoms of each element equal on both sides of the reaction or equation. So if you have 100 atoms in the reactants or in the initial substance, there must be the same number of atoms after the reaction. That is to prove or to conform with the law of conservation of mass, because matter is neither created nor destroyed, and the atoms only undergo rearrangement during chemical reaction. So to explain it further, let's have this illustration. So you will notice two kinds of atoms represented by the green sphere and the light blue sphere. So we have 3 smaller atoms and 4 bigger atoms. So notice their positions in the reactants, and then after the reaction, what happens to the arrangement? The arrangement was changed. So atoms did undergo rearrangement. So after the reaction, their positions are already different. But the numbers of atoms of the two kinds of atoms remain. We still have, after the reaction, 3 green atoms and 4 blue atoms. So that illustrates the conservation of matter. Okay, in another way, okay, let's have this example. 1 mole or 1 molecule of hydrogen reacts with 1 molecule of chlorine to form 2 molecules of hydrochloric acid or hydrogen chloride. So we have 2 hydrogen in the left side of the equation and 2 chlorine. After the reaction, we have the same number of hydrogen and chlorine atoms, but the arrangement of atoms was altered. So again and again, chemical reaction only causes atoms to be rearranged, but they are the same. They are neither created nor destroyed. Okay? In terms of mass, you will see that the initial mass is the same as the final mass. Because you have the same number of atoms, you expect the same number or the same mass. Because no atom was destroyed or created. So the same number of atoms, the same kinds of atoms are present on both sides of the equation, therefore the same mass of the substances. Okay? So I hope that's clear. Let's have this example, going back to our example earlier. We have written the reaction earlier as H2O forming hydrogen and oxygen gases. So how do we balance equations? Initially, water has 2 atoms of hydrogen and 1 atom of oxygen. After the reaction, there are 2 atoms of hydrogen and 2 atoms of oxygen. This is the reason why we need to add certain number in order to adjust the numbers of atoms. So what do we call these numbers being added to formulas or symbols in order to help us balance the reaction? You call these numbers coefficients. So in this example, we have 2 coefficients added. 2 in front of water and 2 in front of hydrogen gas. Okay? So, adding 2 will mean changing the numbers of both elements in water. So, adding 2 will mean new number of hydrogen and new number of oxygen. So, again, initially we have 2 hydrogen and 1 oxygen. After adding 2, you have a new number of hydrogen. So how do we get 4 here? We multiply the coefficient by the subscript of that atom. So in the case of hydrogen, there is subscript 2. You multiply that by the added coefficient 2. So that will give us 4. For oxygen, we have none. No subscript, so that is understood to be 1. So that subscript 1 multiplied by the added coefficient 2 will give us 2. Changing them, we'll have to consider atoms in the right side of the equation. So you will see here that hydrogen in the initial equation is 2 and oxygen is 2 and oxygen not 1, correct that? That's 2 oxygen. So initially we have hydrogen equal but oxygen unequal. We have 1 in the left and 2 in the right. So this is the reason why we are balancing equation, to have all the numbers of atoms of each element equal on both sides. Again, a correction for the right side, the initial number of oxygen atom is 2 because of the formula of oxygen gas, which is O sub 2. So in order to make these numbers equal to the numbers in the left side, we need to add another coefficient, this time in front of hydrogen gas. Why do we need to retain no coefficient in oxygen? It is not necessary that when you add a coefficient, you will have to add coefficients to all the substances. It is also not necessary that if you add coefficient 2, you will use coefficient 2 for the rest of the substances or for the rest of the needed coefficient. Balancing equation is a trial and error. So you just try small numbers because balancing considers the smallest numbers of molecules or smallest coefficients to balance. So after putting 2 here, hydrogen in the right side becomes 2 times 2 equals 4. Oxygen remains to be 2. So having the same numbers of hydrogen and oxygen gases on both sides, making the equation now balanced. So that's how we balance chemical equation. Let's take another example. So we have here diphosphorus pentoxide combines with water to yield phosphorus acid. So in this case, in this example, we have 3 substances. We have diphosphorus pentoxide, water, and phosphoric acid. So if in the first example, we have 1 reactant, this time we have 2 reactants because the sentence goes diphosphorus pentoxide combines with. So that substance is being reacted with water. So the 2 reactants here are diphosphorus pentoxide and water. So their chemical formulas are P sub 2, O sub 5, water is again H2O. The single product is the phosphoric acid with the chemical formula H3PO4. So, as additional guideline, take a look at the initial numbers of hydrogen. In the left side, we have initial. That's before putting coefficient 3 and coefficient 2. So initially, with coefficients 1, 1, 1, and 1, 1, and 1, hydrogen in the left side is 2. Hydrogen in the right side is 3. For ratio, 2:3 or 3:2, the nearest number of atoms that they can be equal is 6. So, be that as the first step for such a complicated equation. So, how will you make 2 in the left side, hydrogen in the left side 6? So you simply add coefficient 6 in front of the whole formula, water. So adding 3 in front of the formula of water, you will make hydrogen 6. So that's subscript 2 times coefficient 3 equals 6. So after making that 6, you go to the other side of the equation, make the number of hydrogen atom the same as 6. So if it's initially 3, then you add 2 to make it 6 as well. So adding coefficients to these 2 substances will result to change of the number of atoms of the other components, no, in the formula. So in the case of water in the left side, you have initially 1 oxygen. After putting coefficient 2, that becomes 3. Okay, that becomes 3. But notice oxygen is also present in the other substance in the left side. We have 5 oxygen in diphosphorus pentoxide. So adding up oxygen from that substance and water, you will have a total of 8. Let's go to phosphorus. Phosphorus is initially 2. That 2, after putting 2 in the right side, in the product side, becomes equal already. So, the number of atoms of phosphorus is now equal by putting 2 in the right side. So, in that case, you don't need to put any more coefficient in front of diphosphorus pentoxide. So, that's another guideline for balancing. So, if you have an initial ratio of 3:2 or 2:3 for an atom, for an element, so you make them equal with 6. So, if it's not equal, then the next multiple of that number, 12. So, you can make them equal and the rest follows. Next. Okay, for this example, calcium reacts with phosphorus acid to produce calcium phosphate and hydrogen gas. So, this is another complex reaction, more complex than the second example. So, as a guideline, look at the complexity of the formula. So, calcium is simply an element. So, the chemical symbol is used here in the equation. Phosphoric acid is H3PO sub 4. So, that's a complex already because of how many atoms? 3 hydrogen, 1 phosphorus, and 4 oxygen. So, that gives you 8. Initial number of 8 atoms. In the product side, we have calcium phosphate, Ca sub 3, quantity PO4 sub 2. So, you know why phosphate is enclosed in parentheses because of the crisscross method. The subscript 3 of calcium came from the numeric charge of phosphate. The numeric charge, the subscript of phosphate came from the numeric charge of calcium. So, by crisscross method, you have learned that in our previous lesson. You crisscross, and then if you are crisscrossing 2 or greater to a polyatomic ion, you enclose that polyatomic ion in parentheses. So that's what happened here. So notice that it's more complex than the first two, right? And the last one is another simple. Hydrogen gas is H sub 2. Okay, so you choose the most complex. The most complex from position 1, position 1, 2, 3, and 4. The most complex is in position 3, the calcium phosphate. What makes it complex? The presence of the use of parentheses makes it the most complex among the 4. What makes it complex is the presence of 2-phosphate, the polyatomic ion phosphate. So you start balancing the equation with that number of complex ion. So how many phosphate ions are there in 1 unit of calcium phosphate? We have 2. In the left side, notice we only have 1. So you first balance the number of phosphate ions. So if you have 2 in the left side, you make it equal to the phosphate ion in the right side. So how will you make it 2? You add, you don't change the subscripts of formulas. You never do that. You don't add subscript also. You can only add coefficient when balancing. Again, never change subscripts, never add subscripts, or never add numbers in between symbols of elements in a chemical formula. By balancing, you only add coefficients in front of the formula. So that's the only way you can balance equation. Okay, so in this case, to balance the number of phosphate ion, you add 2 in front of hydrogen phosphate or phosphoric acid to make the number of phosphate 2. So making that 2, you make that equal to the phosphate ion in the right side. So the phosphate ions are already equal on both sides. So the addition of 2 will help you balance the atoms of the other element. So you put 2 in front of phosphoric acid will cause change in the number of hydrogen atoms. So 3 of hydrogen atoms hydrogen in the phosphoric acid times coefficient 2, added coefficient 2 will give you 6. So that 6 is the new number of hydrogen because initially it's only 3. So after making it 6, you check the number of hydrogen atoms in the right side. It's initially 2. So 6 versus 2. How will you make 6 also the number of hydrogen atoms in the right side? You also add coefficient 3 and the rest will follow. So again, what are the new numbers of atoms of each elements in the equation in each side? We have calcium 1, hydrogen 6, phosphorus 2, 1 times 2, coefficient 2, oxygen 4 times coefficient 2, 8. So that's another guideline, no? When balancing complex equation, you take a look at the most complex and you start balancing the number of ions. Let's go to the 4 types of chemical reactions. So we have 4 fundamental types of chemical reaction: the combination, decomposition, single replacement, and double replacement.